This is Unit 3, Video 2. We are looking at adding forces in Part C. So adding forces, remember right now we're using the American unit for force, which is the pound. So in Part C we have 50 pounds east plus 50 pounds north, and we want to know the resultant vector, or the sum. So first let's draw a picture here. So we have 60 pounds to the north, and we have 50 pounds to the east. And the sum, we use the parallelogram method. Starts here and goes to here. So there is the sum. There are some right angles here. So this is a right angle, this is a right angle, and really here, that's also a right angle. I'm going to get rid of that one so it's not in the way. Right angles means we can use the Pythagorean theorem. So we use the Pythagorean theorem to find the length of this sum vector. So I'm going to put this more in physics terms. Sum squared equals 60 squared. This leg is 60, just like this one is, plus 50 squared. So I'm not going to show all the math work here, but square this, add them together, take the square root of everything, and we find the sum equals 78.1 pounds. The general direction is northeast, but it's not exactly northeast. So in the blank here, let's go ahead and write 78.1 pounds. But we want to be more specific with the direction. And so what we're going to do is find this angle here. And we're going to call it theta. So we are looking at this triangle, and it's a right triangle. So what we are doing, we have an opposite, we have an adjacent. Remember our SOHCAHTOA, tangent is opposite over adjacent. So the tangent of theta equals the opposite over the adjacent. And we are going to put this in our calculator as the inverse tangent. And so we find that theta equals 50.2 degrees. And it is specifically 50.2 degrees north of east. Here's our east line. We are going north of east. So we have 78.1 pounds, and it is at 50.2 degrees north of east. Similar example, we have a vector 50 pounds north, and we have a vector 60 pounds to the southeast. So erase that. First, we're going to draw a picture. So here's kind of a basic grid. Our first one is a different color. Here, 50 pounds north. So that's 50 pounds to the north. Then we have another one that is 60 pounds to the southeast. Since it just says southeast, we're going to imagine that it is directly to the southeast. So let's, I guess, stick with the orange. Here we go. This is 60. And directly to the southeast, we would imagine that this is a 45-degree angle and this is a 45-degree angle as well. Let's do the parallelogram method. So I'm going to draw this line up. I'm going to draw this line in this direction. And we're about to draw the sum, but something I would point out is that we have a right angle right here. Maybe helpful for later. So the sum vector starts here and goes to right there. This is the sum. For one like this, it's going to be best to use our values separated into the i's and the j's. So this is something that you may have seen in math. So we have 50 pounds north. We're going to separate it into two pieces. Its I component and its j component. So going alphabetically, we're talking about horizontal and talking about vertical. Maybe put it in another color. We're talking about basically x and y with different letters. So 50 pounds north has no horizontal component. It is completely straight up and down. Its horizontal component is 0. Its vertical component is 50. Then we have 60 pounds southeast. We're going to separate it into its i's and its j's as well. So this one may be a little bit more difficult, but if we take a look at this, we're looking at this vector specifically. And some things to note, we have a 45-degree angle here, we have a 90-degree angle here, and that means that we also have a 45-degree angle here. So we have a 45, 45, 90 triangle. All right, to keep this clean, I'm going to just draw a separate triangle here. There's 90, there's 45, there's 45. When you have a 45, 45, 90 triangle, if both of these sides, which have the same length, have a length of 1, the hypotenuse has a length of square root of 2. Here's what we're looking at. We are looking for I, the horizontal component, and we are looking for J, the vertical component. So when we're looking for J, here, we're talking about the, excuse me, from this angle, the opposite over the hypotenuse. Sine is opposite over hypotenuse. So what we have is the sine of 45 degrees equals J over 60. The minimum step that you would show in your work is J equals 60 sine of 45 degrees. So you could skip the top step, but this is your minimum showing your work step. And so we find that J equals 42.43. You could do the same thing to find the I, but these sides are going to be equal in length. So for the I, the horizontal, we have, same as the J, 42.43 I. And the J, we have 42.43 as the number, but you have to include direction because J is going to the south or going down. On this grid, it is actually becoming negative. This is 0, this is negative on the J's. To find the sum, we add these two things together. Sum of the i's, sum of the j's. So adding 0 to 42.43, this is the I component. 50 minus 42.43, and this has the j component of positive 7.53. I'm gonna box this off. This is important. Draw a line here. So working over here, I'm going to draw a triangle here. So on this side is the sum. This is my vertical or j component, 7.57. And this is my horizontal component, 42.43. These are the numbers from the sum. So when we want to find the sum, again, this is a right triangle. We can use the Pythagorean theorem. So the square of the sum equals 42.43 squared plus 7.57 squared. And so we solve for it and we find that the sum equals 43.1. We also need to know the angle here. That didn't work very well. So we want to find theta, this angle. We have an opposite, we have an adjacent. So this tells us we're going to use tangent. So here's some minimum work for us. Theta equals inverse tangent of 7.57 over 42.43, which we find is an angle of 10.1 degrees. So back up to here. The sum we found as 43.1 pounds. We found that one here. That's the length of this. And at an angle of 10.1 degrees, and that is north of east.